Hi everyone. We are we are the Raytheon SCOPE team, and this year we looked at measuring material impacts on radio frequency electronics. The team is Lisa, TJ, Tom, Ezra, and I'm Logan. And first we'd like to kind of thank all the people who helped us get here. Of course, our Raytheon liaisons and all of the support we had from Olin. We couldn't have done it without you guys. And into the project. So this year, our team worked with Raytheon, which is a defense contractor known for their work in high-frequency electronics. We're actually working as a continuation from the SCOPE project from last year, and one of their final deliverables was that they identified magnetic materials as a promising direction in our project space. So a lot of what we did this year was focused on investigating how adding these magnetic materials to the surface of printed circuit boards can improve passive components. So a little bit of background. Printed circuit boards, or PCBs, are ubiquitous in modern electronics. They're in everything from a TV remote to your phone to your car, so they're really important in kind of our day-to-day life, even if we don't see them. Maybe you have seen them if you kind of took something apart, as in the image on the right. These are made of an insulating material and copper, which actually carries the electric signal. It's important to note that there are two main categories of types of components inside these PCBs. There are active components and passive components. Active components get smaller and smaller as technology advances, but this hasn't been true for passive components. You can see an example of this in the 2-scale drawing on the right, where the red and green regions represent 50 active components, but the gray region represents only one passive component, so it's kind of very different in terms of scale. So we looked in this space of reducing the size of these passive components because this can make circuit boards cheaper and more compact. So reducing the size of these passive components specifically is important because as individual components get smaller, the entire circuit can get smaller. This means that less material can be used and that can save a lot of money. So we worked on a lot of things this year, but one of the main project goals we're going to talk about today is how we developed tests and criteria for observing the effects of these magnetic materials added to the top of printed circuit boards. So an overview of the process. First, we designed test circuits. This was important, so we actually had something to evaluate. Next, we would simulate that circuit on a computer software to predict exactly how it would behave. Next, we would get our physical boards and measure those circuits so we could gain data to evaluate. Then we would add the magnetic material as identified by the previous team, test it again, and then we would analyze that data to see what effect we had. So first, we had to design those physical boards to test. We needed a standard board so we could compare measurements one to another. We made a few test vehicles, and this was one of the more simple ones that we made. And this lets us take data and compare different materials to one another. Next, we created a simulation of these same boards. We designed our boards based on research, and then we checked them in ANSYS software. This is an example of what one of those simulations looked like. You can see it's just about an exact copy of the circuit we ended up making. And this let us know what to expect before we actually received our physical boards. So after we ordered our boards, received them in the mail, we needed to actually measure them. So we used this machine called a component analyzer to collect that information. And this data collection let us kind of analyze and make decisions about which materials would be most promising. So now we need to actually add our magnetic materials. Many of the materials were identified by the previous year's SCOPE team, but we also did additional research and found a couple of our own that we wanted to test out. You can see an example of how we added it just to the surface of a printed circuit board in this graphic, where the gray area is the magnetic material. This allowed us to actually measure these materials on our test circuit boards. So as I mentioned before, we would apply these materials after taking an initial round of testing. Since we then had data from the board before we added the magnetic material as well as after, we could get a really good direct comparison of exactly what effect this would have. After we collected this data, we analyzed our results in a huge variety of ways. This is one of the example plots we created where you can see the effect on the resonant frequency of one of our magnetic materials. The red line is the kind of before measurement of the board on its own, and the blue line is the measurement we took after adding one of our candidate magnetic materials. You can see that this had a really noticeable effect on the resonant frequency of the inductor, and plots like this, along with others that we made, helped us decide which of these materials were most promising for future use. So finally, our findings were that 2 of the 6 materials that we tested were most promising for use in this planar circuitry that we tried out. These 2 had the most significant positive effects on our circuits. We also know that future use could involve determining an actual mathematical model to characterize the effects of these inks and predict exactly how they could continue to impact future circuits. Thank you.